We're going to spend the rest of our time talking about systems of equations. You've already done this before, last year or the year before, I don't remember. A system of equations is where you have two variables and two equations. For every variable you have, you need to have an equation for it. So if I wanted you to solve for x, y, and z, you would need to have 3 equations. If I wanted you to solve for 5 different variables, you would have to have 5 different equations. Okay? Remember I had an extra credited problem or assignment, it was a problem, in my pre-calculus class when I was a sophomore. And we had A through J were the letters we were solving for. So that's how many different equations we had to have. Yes. Okay, so pre-calculus when I was a sophomore, yes. High school. Yes. I skipped geometry. Different story, different day. So there's 2 different ways to solve a system of equations. One is graphically, one is algebraically. I hope to do both of those today, but we'll see how your pretty little math brains are handling after we finish the algebraically. We might do the graphically next time. No. Now, algebraically, there's 2 different ways to solve algebraically. There's substitution and elimination. Most people like substitution best, so that's probably what we will focus on today, simply because that perhaps is what you're most familiar with. I personally like elimination better, but it's okay, whatever. Now, substitution is best used when you already have y by itself, or x by itself, it doesn't matter, or it's easy, like this one, to get them by itself. So in this one, if I wanted to get x alone, I would just subtract the y, 1 step, we're done. So that's when we would use substitution. If one variable is already isolated, or it's already alone, or it's easy to get one variable alone. Now, if I already know that y equals 2x, I can look at my second equation, and everywhere there's a y, instead of putting y, I could put 2x, right? So our whole point is to get rid of all of the variables except for one on one of those equations. So I'm going to rewrite it, 2x plus 2 times y, we'll fill that in just a second, equals 18. But I don't want to put y there because that still is two variables in the one equation. I want to change it so they're all x's. Instead of putting y, you will put 2x. This right here goes right there. So now I just have to simplify the left and solve for x. 2x plus, what would that be? 4x equals 18. 6x equals 18. So x equals what? 3. That's my first answer. Now, if x is 3, could we solve for y? We're going to take that 3 and we're going to put it in right here. You could use either equation. You always want to use the equations that's the most simple. If I plug it in here, then I have to solve for x, or solve for y. Right here, y is already by itself, so y equals 2 times 3. Y equals 6. How familiar is this to you? Very? Just a little bit. Too familiar. Well, in that case, I really would like to show you elimination.
No.
Please. I like it better. It's my favorite. I know everything. Not really. Okay. Now, notice this one. Substitution. I would substitute on this one. Y is already by itself. This one it's not, though. So I would have to do something to get y by itself. Or, I notice, if I were to multiply this entire equation by 2, and I'll tell you why I picked 2 in a minute. If I were to multiply the whole thing by 2, I would have 2x plus 2y equals 0, right? 2 times x, 2 times y, 2 times 0. You can ignore that now and look at those 2. This is elimination because I'm going to completely eliminate one variable. If I were to add those 2 rows together, what would happen? Adding those 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, Nope. 0, because you have a negative 2 and a positive 2. So I multiplied this by 2 so that my y's would cancel. Equals 16, because 16 plus 0 is 16. So now, very quickly, what does x equal?
4.
X equals 4. Which one was faster, substituting or eliminating? I think the elimination was a little bit faster. I like it better. It depends on the problem. It really does. Yes. 2 times 0. Yeah. So x equals 4. The plugging it back in isn't always as nice. You could use any of these 3 to plug it back in. Which one do you think is the easiest? Probably the one I scribbled out. So if I plug in a 4 right here, 4 plus y equals 0. So y equals negative 4. Which, yeah, I like that one better. It doesn't matter what you do. I think the homework assignment says solve by substitution. We're going to do both. We have 2 more examples of this. We'll do both. Whatever your preference is, go for it. If I can eliminate easily, I will. If I have to change both equations, yeah, I probably still will. I like it better. So let's try part C. On part C, what do you want to do? If I'm comparing C with D, if I want to eliminate on one of them, or if I want to use the substitution on one of them, which one would be easier to do the substitution on? Probably D, right? Because y is already alone. I'm not going to manipulate that back so that I can eliminate. Y is already by itself, so let's do this one by elimination. What would I multiply by to get rid of a variable? Probably negative 4. If I multiply by negative 4, which variable goes away? The x. So let's do that. Multiply this by negative 4. Negative 4 times a negative x is a positive 4x. Negative 4 times a positive y is minus 4y, and then equals minus 4. Is that okay? Let's just make sure. Negative times a negative is a positive. Negative, negative. And then we can ignore that middle one. When I add my newly created line with the bottom line, what happens? Sorry.
Oh, sorry. Apparently somebody listened to one of my videos and the audio went weird and it sounded like I was like a man robot. And the visual was fine. It was keeping up, but it was like, it was, anyway. So if you ever have to listen to one of these, sorry if I sound like, I'm kind of obnoxious to listen to anyway. So like the man version of me is probably not pretty. Okay, so what's this? Combine those, we get what? 4y equals, combine those, we get negative 24, negative 4 make a negative 28. Divide by 4. Y equals what? Negative 7. Now which equation will I plug that into? Probably the one I crossed off again, I would think. If we're looking at that one, I've got negative x and then plus y, so minus 7 equals 1. Add the 7, right? Negative x equals 8. Don't forget that it's a negative x. If negative x equals 8, then positive x would be negative 8. Done. I did that one by substitution last time. It just takes, there's a lot more steps. Do what you want. I like that one better. Okay, part D though, y is already by itself, so I probably would solve this one by substitution. I'm going to take this right here and plug it in to my y from the top equation. We're substituting. When I do that, so I'll just write this out, negative 8x minus 3 times whatever I'm plugging in equals negative 8. What am I plugging in? And then we solve for x. So the substituting, not too hard. It's the solving right here that takes a lot more work. Notice on this one, we just had to divide by 4 and we were done. It's this part that you're going to make your mistake on.
when you're substituting. So to simplify this, I leave the negative 8x alone. We have to distribute that negative 3. So 3 times 16, 48. Has anybody done that yet? Negative 48. And then negative and a negative would be a positive. 3 times 6 is 18x equals negative 8. Let's combine the negative 8 and the positive 18. So 10x equals, now what am I going to do with that negative 48? Add it. 10x would be 40, so x equals 10. Once we have that, finding y is a lot easier with substitution, because you don't have to solve for anything. 4. So picky. X equals 4. Yes. Thank you. Sorry. Plugging that back in now, one clearly is easier than the other. Y is already alone here. Y equals 16 minus 6 times 4. 16 minus 24 would be what? Negative 8. Check my arithmetic. I think I got it this time. Okay, so those are linear. Is that okay? Any questions with those? Do you remember doing those in the past? Yes. Now, today our focus is going to be what happens if they're not linear. How is part A here and part D there? How are they different? On part A down here, we have a what kind of an equation?
Oh, they're both equal to the same.
Okay, they're both equal to y. That's nice, which means I will be doing substitution. But this top equation is quadratic, right? Which means it's possible we're going to have more than one answer. Like this is one group of answers. It's possible we'll have two groups of answers, and you'll see that in just a second. So let's look at part A. They're both equal to y, so I'm going to substitute one for the other. What I'll end up doing is I'm going to take this right here, and I'm plugging it into the y right here. Yes, that's what we will do. So, write that down again, negative 3x plus 12. That's my y, right? That's my y that I'm substituting right here. Equals x squared minus 11x plus 28. So now we have a quadratic equation. So this is a good reminder, a good review. How do you solve a quadratic? There's 3 ways to do it. They are, well, there's 4, graphing. We're not going to do that one. You could factor, you could complete the square, or you could use a quadratic formula. Almost always I'm going to try factoring if I can. I can tell that I've almost lost you. Let's do these 3 and then we'll be done for today. Sound good? End is in sight. You feel better about that? Okay, everybody just took a big deep breath, and I saw it happen as soon as you could see that we were almost done. Okay, so we're going to factor if we can. In order to factor and solve by factoring, I need to have everything on one side. So it has to be a bunch of stuff on one side, 0 on the other, which means we have to get rid of the minus 3x, we have to get rid of the plus 12. To get rid of the minus 3x, we do what? Add 3x. This is great fun because it really incorporates everything we've done this year. I love it. Minus 12, minus 12. So now everything's gone from the left. All of our variables and numbers are on the right. Let's simplify the right. X squared, what? Minus 8x. Minus 16. Nope. Yes? 16?
Yes, 16.
Oh my gosh. Plus 16. Thank you. Now, for those of you that weren't in my class when we studied factoring, how do I factor this? We go up to the side and we play the game. The game is, I need to find 2 numbers that multiply to the outside. In this case, it would be 16. So if you know this, don't yell it out. 2 numbers that multiply to 16 and add to negative 8. So think of 2 numbers that multiply to 16, add to negative 8, 4 and 4, right? Now they both are going to have to be what? 4. Now how do I take those numbers and factor this? What do I do? If this was anything other than a 1, we would have to split the middle term and factor by grouping. We will review that eventually, but not today. This is not 1, so we don't have to do that. This factors down to x minus 4, x minus 4. If this is anything other than a 1, you have to factor by grouping. You could factor another way, but it's much harder, so I didn't even teach you that way. Factor by grouping. How do I solve this now? If we want this to be 0, either this has to be 0 or that one has to be 0. They're the same thing. To solve for x, I'm going to say x minus 4 equals 0, which means x equals what? 4. If these two are different, if that was x minus 4 and x minus 2, I would have given another line right here. So this is my first answer. When I plug it back in up here, y equals negative 3 times 4 plus 12. Y equals what? 0. That was nice.
Oh, yeah.
Excuse me. So that means this right here was a perfect square. There's only one solution. If I were to graph it, it would come, it would kiss, it would go back up. It only hits once. Okay. Looking at this one, let's do the same thing. They're both y, so I'm going to substitute one in for the other. When we rewrite that, I will say x minus 1, that's the y from down here, brought up here, equals 2x squared plus 13x plus 15. So, we said before, anytime that's not a 1, you're going to have to factor by grouping. In order to solve this, everything has to be on one side, right? Don't put it away. In just a few minutes. I have to get rid of the x. Be very careful how you're lining these up. The x and the x have to line up. The constant have to line up. Don't combine that x with the 2x squared. It's not going to work. Combine like terms together. So those cancel. Add the 1, add the 1. So you have 0 equals what? 2x squared plus 12x plus 16. Now, we said anytime that number is something other than 1, we have to factor by grouping, except for if they have the same number in each term. If they have a common factor, we could divide the common factor out. It makes the problem much easier. The common factor is 2. If I divide 2 out, I have 0 divided by 2 is 0 equals x squared plus 6x plus 8. A much easier problem to factor than 2x squared plus 12x plus 16. So off to the side, we'll play the game. I need two numbers that multiply to what? Multiply to 8. If you know it, don't yell it out. Let's let everybody have a chance to think of it. Add to 6. Two numbers that multiply to 8, add to 6. Are what? 4 and 2. 0 equals, if it's anything other than 1, we have to factor by grouping, but in this case we don't. You will one day. Today's not that day. And then how do I finish this off? I set this equal to 0. X plus 4 equals 0. X equals negative 4. That's my first x. I set this equal to 0. X equals negative 2. So that means I'm going to have two sets of answers. When x is negative 4, y is going to be something. When x is negative 2, y is going to be something. If I were to graph these, the first one would look, I don't know, something like that. And the line would look something like this. It means that line and the parabola cross twice. This would be one answer. This would be the other answer. We just have to figure out what those are. We're going to use this equation right here because it's easier to solve for that. If x is negative 4, y equals negative 4 minus 1. I'm plugging it in right here. What would y be? Negative 4 minus 1 would be negative 5. If x is negative 4, y is negative 5. Let's do the same thing if x is negative 2. If x is negative 2, plug it in, what do we get? Y equals negative 2 minus 1, y equals negative 3. So it is possible when you're dealing with a quadratic, when you're dealing with a circle, which we may have to do, that we're going to have two sets of answers. If x is negative 4, y is negative 5, that's one set. You could also rewrite this like this in an ordered pair. That would be a way to write that solution. This would be a way to write that solution. Bounces a lot, sorry. Okay, one more and we're done. Woohoo! Okay, where do we start? Where do we start with part C? We could plug it in. I think the easier way to do it would be to add y first and then plug them in, like one side equal to the other. I don't know, that may not be true, but let's try. So this one right here, if we add y, we'd have y equals 3x, right? So we're taking that minus y and we're bringing it over here basically. And then I can take that 3x and plug it in right here. And then we have to bring it back, but I think this would be easier. So I've got 3x equals x squared plus 4x minus 2. Then what? Subtract the 3x. 0 equals x squared plus x minus 2. Then what? What next? You're like 30 seconds away from freedom. Answer my question. What do we do next? We have to play the game, right? When we're setting up the game, it has to multiply to negative 2, add to 1. The nice thing about 2 is my choices are 1 and 2. Which one of those would have to be negative in order for the entire thing to be positive once you add them together? The 1 has to be negative, good. Because if I multiply those two, I get negative 2. If I add them, I get 1. Perfect. So what do we do with those two numbers? 0 equals what? X plus 2, x minus 1. It doesn't matter what order you put them in. Now what? Now we need to set each of them equal to 0. I hope this silence means I'm so done, not I have no clue what you're saying. That's what we're hoping for. On this one, x would equal what? X equals negative 2. On this one, x equals 1. Now what? If x equals negative 2, what does y equal? Come up to this equation. It's probably the easiest. If x equals negative 2, y equals what? 3 times negative 2, y equals negative 6. If x equals 1, y equals 3. Dun, 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 dun. That's it today. How you doing? If we're using this equation, then we'd end up solving it. It ends up being 3.